Identify the oxidized and reduced species in the reaction. In order to identify both the oxidized and reduced species, I first need to know the oxidation states of every atom in the reaction. So that's my first task in order to solve this problem. So I'm going to start with the MnO2, and what I know is that manganese is a transition metal, and so it can have a variety of oxidation states. So for now I'm going to call it X. I know that oxygen has a -2 oxidation state, and I know that there are 2 oxygens in this compound. So if I take X plus 2 times -2, the sum of those values should be equal to 0 because this is a neutral compound. Therefore, X will be equal to 4. So I can write in plus 4 and -2 as the oxidation states for manganese and oxygen. Next, I look at HCl. Hydrogen has an oxidation state of +1 and chlorine -1. Now I get to manganese chloride, and I'm going to say again that manganese is going to be equal to some value y, I need a variable there, plus 2 times the oxidation state of chlorine here, which is -1, and that's going to be equal to 0, and so I get that y equals 2. So now my oxidation state in the product side for manganese is +2, for chlorine is -1. Here I have Cl2 as a free element, and so the oxidation state is going to be 0. For hydrogen it's +1, and oxygen it's -2. So now what I want to look for is what species are changing oxidation states. And I see that manganese goes from +4 to +2. And I see that chlorine, while some of it stays the same, I also see that some chlorine goes from -1 to 0. So when I look at the manganese going from +4 to +2, that's happening because of a gain of electrons, and as a result this is the reduction process. So it's the manganese that is being reduced, or the manganese oxide that's being reduced. When I look at my chlorine going from -1 to an oxidation state of 0, what I see happening there is the loss of electrons because I'm becoming more positive in the oxidation state, and so that is going to be my oxidation process. So the HCl is oxidized to Cl2.